then we're now moving on to using the model output from all the watch, land surface and global hydrological models, which we now have 9, which we included in our intercomparison study. So by using the watch forcing data that run through these models and then comparing the daily output of those models and then comparing against the trends, against how well they're able to reproduce the monthly regime, and also how well they're able to map particular events, like can they do the 1970s, the spatial mapping of it. So that's the 3 lines we go now for comparing the models and then against the observation. It seems also in the work already done in this water MIP intercomparison where they looked more at, that's where they had a larger catchment. They did identify particular that the model were behaving quite differently in regions with snow. So we do see that here also, that in the northern region the models are more apart, and you can have a model that performs very well in a snow-free region, Central Europe, which then is not so well in the northern part. And splitting it a little bit up like that I think it's also valuable for the modelers to get that sort of information, where it goes wrong, where it's good. And in terms of the spatial patterns, in terms of the mapping the large-scale droughts, they are doing well, all of them, and that's mainly because the boundary of the large-scale events is to a large degree determined by the climate forcing, and so in a way that's a complement to the watch forcing data sets. That's doing a good job. So we do get the spatial large-scale drought well mapped by the models. There are a little bit, because such a large-scale drought event would have a lot of internal variability. One catchment has a large groundwater reservoir, large aquifer. So if it was a wet winter prior to the drought, it can sustain flow for a long time. A neighbouring catchment might not have any stores in its area, which will respond then much more quickly. So you see within a drought-affected region, defined by the climate forcing, you have a lot of patchiness, a lot of different behavior because the catchment properties are very different. So that's again then where the model are mapping these differently, because depending on how they parameterize their stores and groundwater response, and overall some of them are responding a little bit too quickly. So it seems like the groundwater stores is not large enough or not slow enough. You do see that in terms of reproducing the lowest flow, but also that they might respond too quickly to precipitation when it occurs. So in real life, this precipitation would just go into the soil and the stores. Some of the models, it pops out as discharge.